Hey everyone, and welcome to today's Explainer. We're going to dive into a totally fascinating shift happening right now in the world of artificial intelligence. Think about it. We're literally moving from machines that just mimic human language to systems that can actually think, solve complex problems, and, well, reason.
So to kick things off, let's chew on this question for a second. Why does AI sound so incredibly smart, yet frequently fail at basic logic? You know exactly what I'm talking about. It's a massive frustration in the tech world right now. We've got these incredible systems writing beautiful poetry or drafting the perfect email, but then they'll confidently hallucinate a completely fake fact, mess up basic math, or, my personal favorite, tell you to put glue on your pizza so the cheese doesn't slide off. Funny, right? But in high-stakes enterprise environments like healthcare or finance, a plausible-sounding but wrong answer is an absolute disaster waiting to happen.
So here's our roadmap for today. First, we'll expose the generative illusion. Then, we'll look at a really cool historical parallel with the cognitive revolution. After that, we'll enter the world of reasoning AI, pop the hood to see how deep logic models work, and finally, wrap up with the massive enterprise upgrade this brings. Let's get right into it. Okay, part 1, the generative illusion, mimicry without meaning. The big takeaway here is that, yeah, generative AI is phenomenal at natural language generation and spotting patterns, but it has some really severe limitations. It totally lacks deep, multi-step reasoning capabilities. It's highly prone to hallucinations, and it genuinely struggles to keep track of long-term context. You see, models like ChatGPT, they simulate language perfectly, right? But under the hood, they're really just operating on shallow statistical predictions. They're basically just guessing the next best word based on mountains of data, without actually comprehending the meaning behind what they're saying. Moving on to part 2, the cognitive revolution repeated, a historical parallel. So we're taking a quick detour back to the 1950s. A huge, pivotal moment in human psychology was Noam Chomsky's book, Language and Mind. Back then, the absolute dominant approach in behavioral science was behaviorism. Scientists literally thought human beings were basically blank slates and that we learned language purely through mimicking our environment and matching outward behavioral patterns. Well, Chomsky completely blew that theory out of the water. He argued there is just no way you can explain the staggering complexity of human intelligence by simply saying we mimic what we hear. He popularized this really beautiful concept, the infinite use of finite means. Chomsky showed that human language actually relies on a deeply internalized logical rule system, almost like we have a physical cognitive organ just for language in our brains. We aren't just parroting statistical patterns. We have this internal grammar that lets us generate a literally infinite number of ideas from a small, finite set of rules. We actually understand the underlying logic. And honestly, this perfectly illustrates the crazy mirror parallel we're living through right now with tech. Just as human psychology in the 1950s shifted away from behaviorism, that outward mimicry, toward cognitive science and internal logic, artificial intelligence in the 2020s is making the exact same pivot. We are actively moving from generative AI, which is essentially statistical pattern matching, straight into reasoning AI, which is built on deep logic and actual structured understanding. All right, part 3, enter reasoning AI, from prediction to problem solving. Let's put these two side by side to really see the difference. On the left, you've got generative AI. It's shallow, statistical, its memory is usually just prompt-based, and hallucinations are a constant threat. But look at reasoning AI on the right. It is deep, it's logic-aware, it maintains persistent context over long periods of time, and most importantly, it gives us verifiable reliability. This isn't just about sounding smart, it's built from the ground up to actually solve problems. So what exactly are we talking about here? Well, reasoning AI refers to intelligent systems that simulate human-like cognitive processes, things like deduction, induction, and multi-step planning to arrive at logical, explainable outcomes. And explainable is absolutely the magic word here. These systems aim to understand exactly why an answer is true. They trace a logical path, they evaluate multiple variables, and they make sure every single step makes sense within a broader sequence to reach a specific goal. Which brings us to part 4, Deep Logic Models Explained, the technical engine. To really get how this works, let's look at some fascinating research from AWS. The core engine driving this is called the Deep Logic Model, or DLM. Basically, a DLM is a unified framework that combines a lower sensory layer, which is your standard deep learning neural network, with a higher-level semantic layer that's based on first-order logic. And the really crucial part? They're jointly trained. What we're doing here is physically forcing rigid, hard mathematical logic onto the fluid, sometimes messy, pattern matching of a standard neural net.
Okay, here's how this brilliant mechanism actually functions in practice. The neural network acts as the sensory layer, right? It processes the raw inputs, like reading the pixels in an image. But then this semantic layer sits right on top of it, and it acts like a bouncer, enforcing logical output structures. Because they're jointly trained via gradient descent, the system actually translates high-level knowledge into a continuous optimization process. Basically, the AI is literally blocked from outputting an answer unless it satisfies those higher-level logical constraints. To kind of ground this, imagine looking at a dataset of blurry handwritten numbers. This is the pairs dataset from the AWS experiment. A standard generative AI would just try to guess what each blurry number is based completely on pixel patterns. But in this specific experiment, the deep logic model was given a strict, explicit rule right out of the gate. Pairs containing mixed even and odd digits are completely disallowed, period. So let's walk through how it handles this. Step 1, the neural network tries its best to identify the raw pixel images. Step 2, the semantic layer steps in and applies that hard rule, no mixed even odd pairs allowed. Step 3, if the neural net guesses, say, an even and an odd number together, the whole system realizes it just broke the logical rule, so it iteratively adjusts its own internal weights until the constraint is perfectly satisfied. The results were wild. By applying this internal reasoning, the AI jumped from a 62% accuracy rate as a plain neural network all the way up to 76% as a deep logic model. It actively corrected its own mistakes using pure logic. How cool is that? Finally, we arrive at part 5, the enterprise upgrade, why this matters now. Let's take all that abstract academic math and connect it directly to some insights from Data Hub Analytics. The real-world stakes here are massive. Reasoning AI completely transforms high-stakes industries. Take healthcare, for example. We're not just guessing a diagnosis anymore, we're charting treatment paths that strictly adhere to established medical guidelines. In finance, it unlocks real-time risk analysis, where you can model complex, multivariable scenarios simultaneously. And in the supply chain world, we're talking dynamic route planning and logistics optimization under very strict constraints, like, say, a sudden port shutdown. Instead of statistical guesses, these industries finally get verifiable, logically sound decisions. So the ultimate takeaway for you here is that enterprises are absolutely desperate for cognitive automation that is safe and, most importantly, consistent. Reasoning AI gives them auditable logic trails. You can literally trace the exact steps the AI took to make its decision. It enforces strict adherence to business rules and compliance. It drastically reduces those costly hallucinations we talked about earlier. And it allows companies to shift from treating AI as just a simple co-pilot to deploying fully autonomous multi-agent systems that can execute complex workflows reliably. It's a real game changer. All of this brings us to one final, really profound question. What happens to our world when machines don't just speak like us, but actually think and reason like us? We are crossing the threshold right now from simple mimicry to true machine cognition. It is an absolutely incredible frontier, and reasoning AI is the powerful engine driving us there. Thanks so much for joining me on this explainer, and keep questioning the logic.